we start with this pyrolysis of oil, how it is done. It starts with raw material feed, PET, and these are carbon black that comes after the pyrolysis. It's a byproduct, and these are the plastic PET feeding materials. And as you can see there's a baling machine also that helps in like baling the PET to make it easier to feed in the reactor, so that like more of quantities can be fed in. So this is the reactor where you feed in the PET materials, and then as you can see this the backside of the cover gas valve, so that like excess gas can vent out, and then you can purge in nitrogen also in order to give the quality of the oil. And then as you go here, this is a 15-ton capacity reactor, and then here are the feeding gas line and the oil line pipelines. There are three feeding like heating zones on the bottom of the reactor, and then the gas that is generated from the reactor is being utilized back in the furnace, and the initial heating usually takes place with the oil that is already been generated from the process. As you can see here, the internal part of this, the bottom part of this reactor is made up of refractory linings, so that the heating zone of the reactor actually takes place in the bottom. And then the entire process has been rotated with the help of gear. Takes about like 12 hours for the reactor to start generating the gas. And from here, actually the gas generates and then travels to a cyclone, and then any impurities is drained out. And from here, the condense and the gas travels from here to another cyclone, and then whatever the heavy oil or the impurities of the gas gets collected in this tank, and then the other gas that travels through these condensers, the horizontal condensers on above, the gas gets condensed and gets collected through this tank, two tanks. And whatever the gas that comes out, excess gas comes out from this oil tank, travels to another separator, and then the entire excess gas travels back to this tank, and then it's reheated. This gas is used to reheat the reactor, and whatever the flue gas that comes out from the reactor, as you can see, I'm just trying to close the view. We have this gear pulley, and then the motors are from Havells ABB. The flue gas that travels from this line goes through another cyclone, and again there are two FD and ID fan. The ID fan actually helps us to suck in the gas to this two scrubber unit, and then from scrubber it goes to the chimney, and that's the entire process how the gas gets collected. And then another one, and this is something that I have always spoken, the recycling gas that's been used back at the tank, used to store, in fact not a storage, but actually the flowability of the gas to make it consistent. And then this is another the end of the process. What happens is the oil that has been actually collected, this is used for the separation of water in case if there's any moisture content, is separated through a process of density separation, and then travel from this. And this is Mr. Yadav, the founder of this project, and he's the main research head of this project. And then this is the tank that actually goes from here, the water tank, and there's a the cooling tower that's been used here. Okay, so This separation is actually density separation, and then the gas, the oil flows through this two new chambers tank, because by this time the moisture comes less than 0.5%, and then it travels where, like the liquid, the oil has been like mixed with some chemicals in order to get rid of some carbon material that gets mixed up with the oil during the burn, and like during the process, which can actually choke the burners during the application. So it's actually used, and this filter